So now it's time to understand the proof of the Cayley-Hamilton theorem. Cayley-Hamilton theorem. So Cayley-Hamilton theorem for the for the controllability. So as we know that the what is the Cayley-Hamilton theorem? You already studied in the mathematics part. So every square matrix A satisfies its own characteristic
Characteristic equation.
equation. Or characteristic equation you can say in the bracket also eigenvalue. Yes or no?
Yes, sir.
Eigenvalue. So every squared matrix A, यहाँ पर हम लिखते हैं almost all the equation. Almost all the equation. Remember. It means determinant of A minus lambda I is equal to 0. Right? It means lambda to the power n plus a n minus 1 lambda to the power n minus 1 plus a is 2 lambda square plus a1 lambda plus a naught equal to 0. This is the characteristic equation. Yes or no?
Yes, sir.
Okay.
Yes, sir.
Now we can satisfy it with this equation A matrix. So we can write here by this equation, by this statement, we can write here a to the power n plus a n minus 1 a to the power n minus 1 plus dot 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 up to the a2 a square plus a1 a plus a naught I equal to 0. If I'm not wrong, it is clear? Any doubt? A to the power n equal to minus of a naught I minus a1 a minus a2 square a square up to the, please tell me, a to the power n minus 1 into a to
A
the
to the power
power
n minus 1.
n minus 1. Okay. Now please tell me, can we write this equation like this? A का जो पावर है वो n के लिए या n से बड़ा होने के लिए, a to the power you can say n or greater than n plus 1, n plus 2, n plus 3, as like this. We can write this equation like this: j is equals to 0 to the n minus 1 alpha j a to the power j. Alpha j means alpha 0, ओके, a i हो जाएगा, ठीक है, अल्फा जो 1, ओके, a अल्फा 2 a स्क्वायर अल्फा 3 अप टू दिस पॉइंट, ठीक है. सो ये कैसे हो रहा है? यू कैन अंडरस्टैंड फ्रॉम दिस ऑल्सो. You can understand this from also. Please slide, please. Okay. You know very well x dot is equals to ax plus bu. Okay. E to the power at is equals to, we have written I plus at plus a square t square upon 2 and like this. You can write here alpha 0 t naught, okay, or t, okay, I plus alpha 1 t a plus alpha 2 t a square and like this plus alpha n minus 1 t a to the power n minus 1. We can write here, yes or no? Please tell me. ठीक है यहाँ तक?
Yes, sir.
Okay. So this may be written as you know that the controllability matrix, or the, we have written the QC, है ना, QC, or you can say the QC as equals to, we have written B A B, है ना, A square B, okay, a to the power n minus 1 into b. From this we have written like this. Okay, and also e to the power at, e to the power at in other term, आपको याद होगा stm के term में, in the term of stm we can write also like this, phi t I, right, phi t a, right, phi 1, let's say phi 1 up to the phi n minus 1 t a to the power, please tell me, n minus 1. Okay, so मैंने आपको बताया था कुछ दिन पहले कि व्हाट इज द मीनिंग ऑफ रीचेबिलिटी. रीचेबिलिटी रीचेबिलिटी बताया था आपको. लेट्स से इफ द फंक्शन जाई इज बिलोंगिंग टू द स्पेस n, ओके, is reachable, then you can say that the zeta is equals to the 0 to t e to the power a t minus tau b u tau d tau. इट इज इक्वल टू दिस. अगर रीचेबल है, मैंने बताया था आपको कि ये कब स्टेबलाइजेबल होगा. Let's say some function is not, lying in the right hand side, some function is some eigenvalue lying in the left hand side, then you can say the stabilizer, then you have to carry that all the right hand sided eigenvalue to the left hand side, right? So like this. So for some value of ut, this from this ut you can steer all the roots where you desired. Yes or no? Yes or no? So you can write this zeta is equals to 0 to tau alpha naught t minus tau u tau, the expression ib, expand करो इसको, ib plus phi 1 t minus tau u tau a b. ओके, देन क्या हो जाएगा जब बताओ, प्लस प्लीज phi 2 t minus tau u tau a square b up to the phi n minus 1 t minus tau u tau a to the power n minus 1 into b. सॉरी यहाँ पे d tau 0 to t d tau 0 to t d tau and 0 to t d tau. Okay, ठीक है. This is nothing but you can say that is the scalar convolution. The scalar convolution, right? So in last you can write here this equation. You can take the b outside and again 0 to t phi naught t minus tau u tau d tau plus you can take the ab now, ab 0 to t phi 1 t minus tau u tau d tau. Okay, and then up to the, please tell me what is the next expression, a to the power n minus 1 into b 0 to t phi n minus 1 t minus tau u tau d tau. और सेम ये इक्वेशन जो अभी हमने देखा था ऊपर में, ये कुछ उसी तरह का है. ये केवल आपका जो किसके फॉर्म में आ गया बेटा, एसटीएम के फॉर्म में. यस और नो, बी ए बी a to the power n minus 1 into b. Yes or no? And the matrix and sorry. क्या हो गया? Then what to write? Please tell me. क्या लिखेंगे? क्या लिखेंगे यहाँ पर बताओ? Integration, yes, 0 to
t
phi 0
phi naught
t minus tau
t minus tau into u tau into d.
very good, very nice. 0 to t phi 1 t minus tau u tau d tau,
into
and
d2
up to the 0 to t
to
phi n minus
n
1
minus 1.
t minus tau u tau d tau, right? And again,
Yes.
to this is the controllability matrix. This one is nothing but the controllability matrix. Yes or no? And what is this? This is nothing but the convolution. Yes, convolution है या नहीं है बताओ? This is the convolution. What is the convolution? Convolution ये होता है ना? Convolution का equation ये इस तरह
Yes,
का
sir.
होता है. So this is the convolution of time varying coefficient with control. Yes or no? U tau is control. This is the time varying coefficient. Okay. So control input with control input. So it means you can with the help of the control input you can steer the time varying coefficient. Yes or no? So it is very very important. It means you can conclude here. You can conclude here the controllability, right? Controllability is equivalent to reachability. अगर आपका सिस्टम कंट्रोलेबल है, इट मीन्स इट इज द reachability, reachable also, राइट? देखो बात यह है कि अगर कोई सपोज दैट कि यहां से आपने कोई आइगन वैल्यू यहां पर था स्पेस में, और सपोज को ये आपने पाथ करके उसको यहां पहुंचा दिया, लेट से, और किसी इससे पहुंचाया, तो इट इज रीचेबल फ्रॉम दिस पॉइंट टू दिस पॉइंट, राइट? सो ये है आपका, ठीक है? नाउ one example, I am just taking the one example and then I will left the class, if you permit me. Question is, find e to the power at for a matrix 0 1 minus 2 minus 3, right? So you can calculate the lambda 1 and lambda 2. Lambda 1 is minus 1 and lambda 2 is, you can calculate, minus 2. This is the eigenvalue. These are the eigenvalues for the above matrix, eigenvalues of a matrix, right? So e to the power at is equals to, you can write here. Please tell me what will be the equation in the terms of like this: lambda naught I plus alpha naught I plus alpha 1 a.
1.
ठीक है?
Yes, sir.
Yes or no? So please,
Yes, sir.
for lambda is equals to minus 1, you can write here e to the power minus t. It satisfies the equation, so you can write simply alpha naught minus alpha 1. Is it clear? Now for the alpha, for lambda is equals to minus 2, this equation becomes, please tell me, e to the power minus 2t is equals to alpha naught minus 2 alpha 1, right? Now find the value of alpha 1, alpha naught and alpha 1. Find the values of alpha naught and alpha 1. You can solve this equation because there are two equations, two variable, right? So when you calculate alpha naught, you will get 2 e to the power minus t minus e to the power minus t. Alpha 1 is equals to e to the power minus t minus e to the power minus 2t, right? So therefore e to the power at become, therefore e to the power at equation becomes, क्या बन जाएगा बताओ जरा बेटा? अल्फा नॉट, व्हाट इज अल्फा नॉट? दिस इज द इक्वेशन, e to the power, हाँ जी बोला बताओ, e to the
E to
power
power
at becomes 2
2
e to the power minus
e
t minus e to the power minus t into
minus
I
into I
plus
plus
e to the power
e to
minus
power
t
minus t
minus e to the power minus 2t a.
e to power into
तो
a.
ये आपका देखिए अल्फा नॉट अल्फा आई अल्फा 1 अल्फा 2 के फॉर्म में ऐसे हम लोग एक्सप्रेस कर सकते हैं, ठीक है, राइट? सो दिस इज द answer, right? So I just I'm here. Okay, so there's also one. Chalo, ठीक है. We will discuss next